Hi, today I would like to talk more about the quadratic formula. If we consider the general quadratic equations, ax squared plus bx plus c, and this is the quadratic formula. If we look at the formula, it means when we solve this one, assuming there will be two roots, okay, this is 1, should be minus b, okay, plus square root b squared minus 4ac over 2a, or minus b minus square root of b squared minus 4ac over 2a. Now, if we look at these two roots, okay, you observe it which part are different. There is a common part, and there's also one part which is different. If you look carefully, you can look at it by separate them into two fractions like that. Now, then in this case, you can see that both of them, okay, have this one minus b over 2a, and also this part square root of b squared minus 4ac over 2a. And the difference is this part. This is plus, this is minus. Now, then if we just look at this structure, it means that actually the roots of quadratic equation come in pairs, okay? And the roots consists of two parts. You can consider in this way, consists of two parts. And the difference is that the sign, okay, connecting these two parts are different, okay? One is plus and one is minus. Now, therefore, in this case, assuming that, okay, A, B, and C are integers, now then I can confirm that minus b over 2a must be real and rational, right? Now, therefore, in this case, if we look at this part, because there's a square root here, and whether the roots are real or complex, where the roots are rational or irrational, whether actually we have repeated roots, it all depends on the values of b squared minus 4ac. This part. It means if we look at this one, we may know that the roots, say, are real. Okay, two real roots. And for real roots, we can have two unequal real roots, or we can write like that: two unequal rational real roots. Or we have two unequal irrational real roots. Or we have double root. Or we have complex roots. Now, then we look at this way. I just want to focus on complex root this time. Now, when will we have complex root? B squared minus 4ac is less than 0, okay, which is a negative number. Now, then in this case, let me have particular value so that you can understand easily. For example, if say b squared minus 4ac equals minus 3. Now, then the roots becomes x equal minus b over 2a plus square root minus negative 3 over 2a, or minus b over 2a minus, okay, negative 3, square root of negative 3 over 2a. If I rewrite it with complex number, minus b over 2a plus root 3i over 2a, or minus b over 2a minus root 3i over 2a. Now, you can see that in this case, we have two complex roots. It means the complex root come in pairs. And these pairs are having the kinds of characteristic. Let me remind you, or let us read it, look at it again. If you look at these two complex roots, you can see that the real parts are the same. But if we look at the imaginary part, this is the imaginary part. Right? They are similar, okay? They are not the same, but they are similar because we can see that both of them are root 3 over 2a, right? But one is positive here and the other one is negative. Therefore, in this case, for quadratic equation, if the quadratic equation has complex root, the complex root come in pairs. And this pair, we call them conjugate pairs. I give you one more example. It means if 1 plus root 2i, okay, 1 plus root 2i is a root, then the other root must be 1 minus root 2i. If, say minus 2 plus 3i is a root. The other root must be minus 2 minus 3i. Okay, these kinds of pair, they are called conjugate pairs. The only difference is the imaginary part. One is positive and one is negative. They are conjugate pairs. Okay, for all quadratic equation having, okay, don't forget this one, having integral coefficient, it means if we look at our general quadratic equation, we are assuming that it to be ax squared plus bx plus c. If a, b, and c are integers, and the equations is having complex roots, the roots must come in conjugate pairs like that. Okay, and similar thinking can be applied to this case. You can try to think about it by yourself. If you don't understand this part, feel free to leave me any comments or ask your teacher.